Hello, and welcome to episode 2 of This Old Math Class. I am again your host, Bruce, the Toolman Corrigan-Salter. Today I want to talk a little bit about building a frame and using Pythagorean Theorem. So the idea here is that I've got a frame made out of wood, but I'm not sure this is the right angle. Now, I could take out my compass and see if I could measure this angle. And it looks like it's pretty close to 90, but there's an easier way to do this, especially if your frame is large. So the way that it works is this. Using Pythagorean Theorem, we know that in a right triangle, so if I build a right triangle right here, if this angle is a 90-degree angle, if it's a right triangle, then the distance from here to here, the length of this leg squared, plus the length of this leg squared, is equal to the length of this leg squared. And this allows us to determine whether or not we really do have a right angle. So now if I'm building my frame and I want to make sure that that stays a right angle, especially if I'm building a frame for like a house or a room, what I can do is I can use an extra piece, the hypotenuse piece for this triangle, and I can nail it in. And where I nail it, if I end up nailing it, now I'm not going to nail right now, but let's just pretend. So I nail it in. And once I've nailed it in, what I can do then is I can measure the distance from the corner to where the piece of wood meets. So here I have 8 3/4. From the corner to where the piece of wood meets. So here I have 13 1/2. And then from those two spots where the pieces of wood meet. So here I've got 16 inches. And I could use that to try to figure out whether or not we have a right triangle. And if we have a right triangle using Pythagorean Theorem, then that means that this really is a right angle. So that's how we can use math, another way to use math, when we're building something, especially if it's a frame where we need to have a 90-degree angle. So let's take a look at that math.
Okay, as you could probably tell from the start of the show, this is actually not too bad when we're trying to use this Pythagorean theorem in the real world. So first of all, and you've probably seen this before, I want to remind you of what the Pythagorean theorem looks like. So the Pythagorean theorem is used for right triangles. So if you have a right triangle, and you have the adjacent sides to the right angle, so we'll call these A and B, and we know the lengths of those sides, we also have the hypotenuse C. And the Pythagorean theorem says that if you take A squared plus B squared, it should be equal to C squared. Now the cool thing about this is that it says that in a right triangle this is true. What we also know is that if this is true, then the triangle is a right triangle. In other words, that angle that we're looking at is a right angle. So now suppose that you have some lengths that you're trying to figure out whether or not they're right angle. It's at a right angle. So suppose that you know this is, say 8 feet, and suppose that you know that this is 5 feet, and then suppose that you know that this is 10 feet. So in other words, you measure the distance from this point to this point, you get 10 feet, from this point to this point, and you get 5 feet, and then that vertical spot, you get 8 feet. Now, does it fit the Pythagorean theorem? Well, 5 squared plus 8 squared, we're asking, is this equal to 10 squared? Now, 5 squared is 25, 8 squared is 64, and 10 squared is 100. Now, 25 plus 64 is 89. 89 does not equal 100. So we've got a problem there, and the problem is that this angle is not a right angle. So you can determine whether or not a right angle actually exists using the Pythagorean theorem. Now, if you're looking at this, then you might say, okay, wait, I'm actually building something, and it's currently at 10 feet, but I could change it. I could actually fix it to make sure that it's a right angle. How do I do that? Well, if you know that this length is 8 feet, and you know that this length is 5 feet, well, then what can you do? You can say, you can call this right here x, so then you have 8 squared plus 5 squared is equal to x squared. You can solve it out. 64 plus 25 is equal to x squared. So 89 is equal to x squared. And what you can do then is that this formula tells that x is equal to plus or minus the square root of 89. Now, it could be the negative version because technically that works out, but if we're working with wood, right? You cannot measure negative numbers, so really we just need the positive square root of 89. So you just take the square root of 89. And so I've got my calculator here. I can take the square root of 89, and I end up getting 9.434. Now that's not that far off. That's only a half of a foot, 6 inches, but it's over a 10-foot span. So it's going to look very close to a right angle the way that it was built, but if you want to fix it, you're going to cut that down to 9.434 inches or feet. And then that's going to give you a much better looking angle right there. It'll give you an actual right angle. That's really all there is to it. Using the Pythagorean theorem means that if you know two of the pieces of information, you can find the third piece of information. And if you have all three pieces of information and it's not equal to each other when you take the sum of the squares of the legs, you don't get the square of the hypotenuse, then it means that it's not a right angle. And so that's the cool thing that you can do with Pythagorean theorem here.